Hi there, welcome back to another installment of the LS5.0 engine project. This will be the last update before we head to the dyno with this engine and turn hydrocarbons into horsepower. What we're going to look at today are the final bits the engine needs to be ready for the dyno, as well as a bonus carbon fiber part. So come along as we get the last bits in place on LS5.0. The first part that we're going to look at is the fuel injectors. We've run DeatschWorks injectors in several other EngineLabs projects, and they have our full confidence to perform under the stresses of our testing. You might remember a video we published a while back where we ran through the math of determining what injector size you need for a given horsepower goal. Well, DeatschWorks has an online calculator that takes all the long-form math out of it and makes life easy. However, when we ran the numbers, not just on phase 1, but on phase 2 and even potentially phase 3 of the project, we came up with an injector size that was right in between two of the sizes they offer. In that scenario, you have three options. Reduce your power goals, yeah right. Push the base fuel pressure and injector duty cycle envelope, which we've done before with solid success, but it's far from ideal. Or simply run larger injectors. After speaking with their tech, they confirmed that our gut instinct to just order a size up on the injectors was the right call. Having too big of an injector is a mostly non-issue these days. And as they pointed out, with our RPM goals, having a bigger injector would be beneficial when it comes to the incredibly small pulse widths we'll be seeing. That led us to DeatschWorks 800 cc per minute injectors, which are dynamically flow matched right out of the box. If you do the math on these, they flow enough gasoline for almost 1,200 naturally aspirated horsepower and enough E85 for almost 900 horsepower. Obviously, we won't be approaching those numbers with a little old naturally aspirated 5-liter engine, but knowing that these injectors will handle anything we throw at it with absolutely no downside, all at the same cost as the smaller injectors, makes it a no-brainer. The next addition to LS5.0 comes in the form of a performance design carbon HR intake manifold lid. When we released the top-end video with the performance design carbon fiber valve covers, many of your comments asked how we could run the carbon fiber valve covers and not a carbon intake. Well, we heard you, and so did performance design. We already had some intake lid testing scheduled in dyno time, and now we have a third lid to test. Besides looking absolutely stunning, the carbon HR lid is lighter and resists heat soak much more than the aluminum lid. Obviously, we're already familiar with the absolute quality of the performance design parts, and the carbon HR intake manifold lid is no exception. Using their high temp epoxy and exposed weave carbon for the body, the plenum flange is a carbon wrap foam core piece, and the throttle body flange is machined out of billet aluminum. One thing they don't really mention in the product info that was immediately apparent to us is that it's not just a direct copy of the aluminum lid in a different material. The plenum shape and volume is noticeably different to the naked eye, and the location of the throttle body flange is slightly different. The carbon HR will accept a 105mm throttle body, and the lid requires zero modifications to fit on a Holley high ram, mid-rise, or low ram intake manifold base. Since we're using the low ram, it's just a matter of R&Ring the lid to swap. Something else to note, which is subjective but still important, is how incredible the intake lid looks. While we are solidly in the function over form camp, when it has both, it's a great bonus. The final piece of the puzzle to get LS5.0 ready for the dyno is the Holley Terminator X fuel injection kit. As we've shown in past projects, the Holley Terminator is powerful enough to do everything we ask of it, while simple enough for someone to jump into with little to no experience with their software and get up and running in a flash. The Terminator X comes in a lot of variants, even for the LS market. For our combination, since it was originally a Gen 4 truck engine, that's what we chose. Ours is set up for a 58X crank reluctor, a 4X cam position sensor, and EV6 style fuel injector connectors, making our DeatschWorks injectors direct plug and play with no adapters or pigtails needed. The kit uses an included Bosch LSU 4.9 wideband oxygen sensor and has a built-in 1-bar map sensor, which means we won't need to run anything external on that front. The kit is available with a 3.5-inch touchscreen controller, which is a nice touch when this goes into a car, but for now, we'll be taking full advantage of the powerful Windows-based software at the dyno. The included harness is plug and play with the specific LS engine it's designed around, meaning there's no splicing or special sensors needed to unlock the full potential of the ECU. Just connect the harness to the factory sensors and bam, you have a fully controllable standalone ECU setup. Now there's nothing left to do but to load up the engine in the back of the truck and head to the dyno and see if all this effort will lead to our planned results or if we're going to have to go back to the drawing board and make a few changes. And before you ask in the comments, yes, there is testing planned beyond just spinning it up and seeing what it makes. Not to spoil the surprise, but we already have plans for version 2.0 in the works where we're going to get even more crazy with this. So make sure you're subscribed to EngineLabs and have the notification bell checked so you don't miss any of the testing and updates on Project LS5.0 or any of our different engine projects. Also, let me know down below if there's anything you'd like to see tested on this engine. You know we read the comments. Thanks for watching and we'll see you at the dyno.